So I'm going to talk today about some of my work using a SMAC toolkit to migrate code between languages. And by migrating code to other languages, I'm not saying migrate away from Smalltalk. I'm just saying migrate from, language A to language B. So the standard development, you can kind of consider, as time goes along, features get added. So it doesn't always occur in a straight line. Sometimes you might remove features. Other times you might, have a bunch of development come in and add a bunch more features, and so it's not really a straight line. It wanders around. But for the purpose of this talk, I'll just consider it a straight line. So at some point in time, it comes to the point where you might say your current programming language or libraries or whatever are not being supported well enough, and that you want to convert those into something else that's better supported. So essentially there's 3 different ways you can do that. One is to basically stop development and then have another, use your team to develop in the new product. So you stop, you cut off all features, so no new features are going in. The team continues or starts developing in the new language, and at some point you get good enough back to where you were, and so you go from there. However, what normally happens is the team doing the new development, they think that we've already done this before, so we can develop it faster than we did before, because we know stuff that we didn't know before. However, in general, what normally happens is that the development speed is kind of close to what they developed before, because knowing the wrong design doesn't imply that you know the correct design. So the next time you develop it just means that you're doing another design of that, and so you'll probably make different mistakes. You might not make the same mistakes, but you'll probably make different mistakes. And so the time to develop the new system is approximately what it took before. So that's the stop and rewrite approach. Another approach is to basically either split the teams into 2. So you might take your smartest people and move them off to a team which is going to develop the new thing, and use your, junior developers to continue on adding a few new features. So, at that approach, what happens is that your junior developers are not going to develop quite as many features as the whole team before. So you got the slope decrease on the line, and the new team is then going to do, like in the stop and rewrite, they're going to replace it. Of course, like the stop and rewrite, what normally happens with any development is you have the new team overestimates what they can do, and so you get a much shallower slope. Now, the approach that I like to use is basically what I call the transformational approach. So essentially what you do is take your old team, let them continue on developing software, hire, a couple of outside people, or maybe in combination with 1 or 2 of the team itself, and essentially let them do that while somebody else will go in and do the transformation approach. So essentially what you're doing is building up a program that's going to run at certain times that will eventually convert everything that they have into this new system. So, as I say, basically the transformational strategy is to create this program. And it's a one-time program, unlike most programs where you have to, consider that the life of the program might be decades. This program might just be, this one time at the end of whenever it's converted. A couple of reasons why people do not like this approach is that essentially, normally when you do this, you have to introduce a compatibility layer, so it's extra code that would not be there for a new development. For a compatibility layer, I'm talking about things like in Delphi has arrays which have bounds. You can specify the bounds on your array, so you can go from -12 to 12. In languages like C or C++ or Java or whatever, all your arrays start at 0 and go. So if you wanted to do the same support in C++ or as you have in Delphi and like C#, you have to actually write classes to perform that support.
The main reason why people do not like this approach is...
So
yes?
the compatibility layer, you think of it as being in the part of the target language, not the...
Yes, it's a part of the target language. So it's a little bit of overhead that you probably wouldn't have if you developed it directly in the language that you're going to initially. But the main reason why people do not like the transformational approach is that it keeps the same design. And whenever you talk about anybody, they always hate how their code looks. And it's always somebody else's fault, and they could do much better themselves. So as we kind of have a saying, if you have garbage in, you'll get garbage out because the same design is the garbage. However, that kind of is a little bit misleading in that probably 80% of the code on a large project will never be touched again. It sits there and runs, and most people can care less what it looks like if they're never going to touch it. So that's the one thing to keep in the back of the mind. Now, so I'm going to discuss a project we did for a company called Profit Stars. The project, or Profit Stars, had a code base that they'd been working on for 20 years, and it was done in Delphi, or before that Turbo Pascal or something like that. It dealt with banks, small banks, so it did some forecasting for small banks. And, they had 20 years development cost in this thing, but they also have declining language support. So Delphi, is not a big sell to most places. The new versions of Delphi were always kind of behind the time, so you might have to wait an extra year to get that support that you wanted to have in there. It was also hard to find developers. Most kids right out of college do not want to go work for something where they're using a language that is kind of on the declining side. So it's hard to find, younger kids. The older people probably are, if they're no Delphi, they're in a Delphi job already and they're not looking to transfer. And one of the other things is that when Profit Stars had been bought by another company, and they want to integrate all their software into one suite. And so if the other company is using C# and .NET, then that wasn't going to work for Delphi. So we'd worked with Profit Stars before, and Don had introduced them to some XP practices and refactored some of their databases, so they were fairly comfortable with us. And when we told them that we thought we could do this project, they believed us. So what the project was basically split into 10 different milestones. So at the beginning, there were small things like, we need the backup program to run. So we'll start with small things like a backup program and a restore program. Then as it progressed, in the middle was some more complex UIs. Then it moved up to they had their own little spreadsheet UI. And finally, the last two milestones were basically have the whole thing running. And each one of these milestones basically was, we could bill for it if it passed their QA, and they could also basically say, this does not look like what we want, and cancel after any of them. So for us, we took 2 migration specialists, myself and Don Roberts, and we asked for 2 of their developers because since we were allowing them to cancel as quick as they wanted to, we wanted them to have a little bit of skin in the game of, by paying for developers along the line. And those developers rotated between the team that they had. So one week it might be one person, the next week it would be somebody else. And the other thing we asked for is their QA team because we're not experts in their software. We need some way to test it. So when we got this, we'd had the SMAC parser generator and some of the stuff already there. We just wanted to extend it to do more transformations. So SMAC is essentially a GLL parser. If you don't know what GLR stands for, it just basically means that it can parse ambiguous grammars, which makes it easier to write the parsers. And with a little bit of annotation, we can extend it to create the AST nodes. And once it has the AST nodes, the SMAC transformation toolkit can use that to do the transformations without any extra work. Now, the toolkit is basically a string-based thing, which means that normally whenever you do transformations, you parse it as a parse tree, and it changes into another parse tree. Whereas this one here, you parse it as a parse tree, but it just does string edit operations on the resulting file. This allows us to do stuff like just write out reports. So you can write transformation rules to just write a report from a source file. So you don't have, there's really English grammar or whatever is not that nice to the parse or whatever you build a parse tree for. One other thing that we added was the ability to see which rules change a particular line in the file. Normally, most of these tools, you just kind of run batch mode, and if you have a problem, you have to figure it out yourself. So here's an example of the Delphi conversion. Up the top left is the Delphi program of Pong that I found on the internet for somebody. And on the top right is the equivalent C# version, in which I've selected some text, and that selection actually has two rules that modified that selection, which one was with the if statement, which deleted the then clause to change it from C# or Delphi to C#, and the other one is the conversion of the or word to the two vertical bars. Now, essentially, there's three types of rules. I kind of went over this yesterday with some of the refactoring stuff, but there's a pattern rules, code rules, and for this project, we also added mapping rules. So the pattern rules are the essential search and replace, search for a parse tree, replace with a string. And here's a few examples for the Delphi code. The first two are standard SMAC. The third one is an extension where we added type support. So you could say that a variable of that type matches, not just any type matches. The code rules are just Smalltalk expressions. So you can do search expressions, and you can base them off a particular type of AST node. And you can also do it on the replacement. You can do either edit operations, or you can do control flow operations or initializations, kind of the three standards. So there's basically a few different examples. The continue is kind of a control flow, but the first two are edit operations, and the last one is an initialization of the class's to remove variable. Now, the third type of transformation that we added, in addition to the standards SMAC toolkits, are mappings. So since we had their two developers that they had, rotating to our team, initially we wanted to give them some work so they're just not sitting around doing nothing for our project. And so what we did was we used the code, parsed the code, and figured out all the references to external Delphi objects. We stuck that into a CSV file and told them to open up Excel and tell us for each one of these Delphi classes or methods what the equivalent .NET is. Because they knew both Delphi and they knew some .NET. Don and I were not experts in Delphi. We'd programmed in Pascal like 20 years earlier, but that's not quite the same. And so they were able to start filling out this table while we were working, trying to get the transformations up to snuff for actually converting Delphi to C#. So in this example, we have things like, the built-in ABS function in Delphi should map to the system math ABS function in .NET. And so you could fill out this table, and it would then convert everything else. So the first two, or the first one's a function, the second one is a constant value, the third one is a type, the TV alignment is a base grid type in Delphi, and the last one is enum. So after basically 1.5 years of this project, we were able to get the program good enough that it convert their program into C#. Essentially 1.5 million lines of Delphi became 1.5 million lines of C#, plus or minus a few lines. They had in Delphi 13,000 automated tests, and we converted all those into be in-unit tests in C#. All of them had to run without any errors. We used essentially 10,000 transformation rules. So that's what we did in our year and a half, was build up that database. One of the things I hadn't talked about is the replacement code. So essentially what happens is sometimes you get some methods that just don't map that well at all. So you convert it, it has 50 compile errors in there that while I could write all the rules to do that, it's just easier for me to go change the method manually. And so that's what the replacement code is basically 26,000 lines of replacement code where we just went in and hand edited the code and did the replacement. Yes?
Yes, that's the stats in hours.
So it was pretty much, so we used our 2 people and their 2 people, although sometimes I think they kind of shorted us some of their 2 people. But we probably sometimes worked a little bit more than 40 hours a week, so it's probably, might as well say four people for a year and a half. I think somebody estimated this, I forget, way over 20 man years is what they estimated it'd take to rewrite it based off of function points or something like that. So, and that was for their whole team, or I think, or well, no, I forget. But it was quite a savings based off their estimates.
When you run a project like this large amount of time to spend on analysis, are you counting that into the picture?
No, so essentially, we didn't really have analysis. We'd worked with the company before. We kind of saw their code, but I never did actually take the code. And since they were more of a company that you could just work from for a handshake, essentially they asked us what it would take, and I thought the code was around 1 million lines. And so I told them a year to a year and a half. And they thought that was fine. And one of the things I found out was it was more like 1.5 million lines instead of 1 million lines. So a year and a half, and that's what we came up with. And we actually meet our initial estimate of a year to a year and a half. And so that everybody is happy there. Now the last one is basically the 2,400 lines. That's the code, like the array, the code that I told about earlier. It's the compatibility library that was needed. So we needed 2,400 lines. I know array was part of it. There's also some serialization code that in Delphi you could just write out structs directly to disk and you didn't have to do anything. .NET, you kind of had to tell it what sizes and where to put it on the disk. So some of the good parts about the project, some of the things that went well. For being a project that is like 20 years old, they still had 2 or 3 of their original developers are old enough that knew the original developers. Unlike a lot of projects I've worked on where none of the developers are around and the developers that they have currently maintaining it don't know anything about the system. So that was a very nice part. Second thing is they had already started to do some C#, so they were at least familiar. And so when we could, give them all the C# at the end, it wasn't as if we needed to train them on C# or anything like that. So they already kind of could read the code. The code came over the same way with the same names for classes, so they could, do some translation in their head and figure it out from their knowledge of C#. A third thing is using their 2 developers, we were actually allowed to kind of refactor the Delphi code sometimes to make the transformation easier. So if they could do the refactoring on the Delphi side, it makes our transformation easier, and it can make the whole process go easier. Whereas if they were not allowed to do that, we'd have to do the refactoring and the transformation at the same time, and that always makes things trickier. And whenever you have a bug, it makes it harder to find what the bug is. So we also had an on-site customer, which meant that if we had a question like, is it all right for the grid to display with this gray of a background and not that gray of a background, they could just answer it right away and say, yes, that's fine, or no, we have to make it be exactly the same. Since Delphi and C#, I believe, were designed kind of by the same person, or had the same person involved in both the designs, they have similar language features, so that made it easier to do the conversion. A lot of things in Delphi had equivalents in C#. Now, we also did frequent regenerations. So basically every day they would give us that day's worth of code that they developed, and we would run the rules that night and give them back the code the next day. And there was a couple of times where they did not get us the code, and the QA reported the bug the next day saying that this had already been fixed and why isn't it fixed in the converted code. And that was simply because we did not have the latest code at the time. So, yes?
Yes, sir. I understand. So you were doing this transformation while the code in Delphi was still being...
Yeah.
Oh, okay.
Yeah, so they developed for a year and a half, continued on, did their releases. I don't know if they had 6 months releases or whatever.
I was going to ask you, because if it took you 11 months to make all this transformation, why didn't you just did that instead of having a tool to do that?
Yeah.
People, I think.
Yeah, so one is, I don't think I could have done that near as fast without a tool. I don't think, a lot of people think that they can do the development of that quick. I really doubt that they can, and most companies that I've seen try that. I've yet to see one that succeeded.
Okay.
So.
And how long did it take you to make the transformation, the tool? How long did the tool take to make the transformation?
To run the tool once I just press the button?
Yeah.
Probably like 10 minutes or so. Okay. So another nice feature is basically the ability to make global changes. So essentially you can make one rewrite change and change every place in the code that occurs. And so you can fix thousands of things at a time by just making the change, rerunning everything. We also had a language expert, I would call. Essentially, you could ask him any Delphi question, and he had an answer for. If you had a Delphi question yourself and you asked Google, you probably went to his blog to answer it. So it was nice to have him on their side that could answer any questions like, why can you pass I think it was an integer into something that expected an integer array. And he said, well, that's just the way Delphi works with one variable integers. Who knows? They also had the automated tests that I talked about earlier. I think it's 13,000, which makes it easier to debug issues if you have some repeatable tests that you can run. And the final thing is the milestones, in which we had concrete points in time where we delivered stuff, and they accepted it, and they tested it, and made it really nice for them to see what the project was doing and for us to get paid at times. Now, the hard parts, essentially every migration project I've ever worked on, the GUI is probably one of the toughest parts because the order of events and when they get signaled. So like one of them on the Delphi project was in Delphi, I think if you set the text of a widget, it did not signal the event that the text had changed if you explicitly set it through code. But, of course, if you typed it in, the widget would signal the changed event. Well, .NET, it always signaled the changed event whether you typed it in or whether you set it through code. So then you end up with infinite recursion of events. There's also issues with library design, where I think for this project we had a reporting framework. The original reporting framework was essentially you told it what to do. So you told it to build the header, build the detail, build the footer. And the framework we went to, it was all, declarative. So you told it what the thing was supposed to look like, but they were in control of when things got built and how they ran. So we had to map a little bit differently on that. You also have things like library bugs. So even though you might even use the exact same library between the two languages, so we had a chart library that we used that was built by the same people. One of the chart, on this side it might have this bug, but on the C# side it might have a completely different bug. So you have to work around issues like that. You have accidentally working codes, like in Smalltalk, common accidentally working code is if you have A and B equals C without parentheses around the B equals C part. Generally, you probably do not want to write it that way. You probably want to do A and B equals C with parentheses. And things like that, whenever you convert them, might not accidentally work anymore. Another hard part was the QA, and whenever you tell QA to report any difference between the two products, sometimes they start reporting little tiny things that really isn't part of the product. But other times, what will happen is they'll find a bug in the converted code, and they'll never stop and check to see if that bug existed in the original code. So we have to actually go through and debug basically stuff that they should have fixed. So that takes away time from us to do the migration and actually is spending time for them. We also had refactoring during migration. So one of the things they wanted to do was combine two different grids into one. So they didn't have two different libraries for the grids. And whenever you do that, you run into problems of what things are specified and what things are not. And we didn't have that up front, so we had spent more time doing that than we should have. For Delphi, memory is either explicitly managed, whether new and free or something like that, or you can do reference counting. And whenever you assign to, I think it's an interface, variables declared as an interface type, it'll do reference counting to garbage collect, which all those have explicit locations in the code where things get deallocated or disposed. In C#, we just kind of ignored most of that and let the garbage collector take care of it. However, for certain things like things that open up files and close them on dispose, they have to be run at proper times, and trying to figure out where to put in the deallocation part for a reference counted interface was sometimes tricky. Delphi also has floating point numbers, which are 80 bits, not the standard 64-bit. So we had tests that would actually use all 80 bits and can do a comparison to exact equal, and so it made some of the tests where we had to rewrite those to work in the C# with 64 bits. We also had issues with managing expectations after the first 2 or 3 releases where we actually got it done beforehand, before time, and everything looked exactly right. Then they start, initially they think nothing will work. Then you show them 2 or 3 where everything works, then they think everything should be perfect. So you have the whole expectation game of managing that over the year and a half. And the final issue we had was Visual Studio, and unlike Smalltalk where you can just accept a method and hit save, and with 10 milliseconds later it's there. Visual Studio, you change your method and hit build, and 2 minutes later you finally got a build. So that adds up to a lot of time. So we also did some VA to Java, but I could talk about that later if somebody wants to talk to me personally, but I'll just skip those slides. So essentially, in my principles that I start with for migrations is essentially you have to be kind of cautious the first time you do something. You can, it's just going to work like the last time, but there's always some gotchas in there. So, for the VA for Java one that I didn't talk about, there's a gotcha for we went to EGL language, and that language was not quite mature enough for what we were doing, and so we had several compiler issues that we had to work with the company to get fixed. Another principle is to be bold. What you want to do is, have one change that fixes every place. You don't want to be timid and, just change it in this one little location. You want to change every place. So, and that kind of builds to fail big. Whenever you make a mistake, you want it to fail every place it's ever referenced. So you want 100% failure versus 90% success, because if you do 90% success, you have the last 10% that's going to kill you from having to fix manually. So with that, I'll open it up for some questions. Any question? Yes. So I have not personally. I have had one project in which I didn't, I've worked on, but I didn't bid on or anything, where it took longer than, it took about they initially bid it for like a year and a half, and I think it took like 2.5 years. But otherwise, everything I've done has been shipped. And even that project got shipped. It was just, a year later than.
Were you able to go part of the system architecture?
So
You're not doing that sort of code to code. What if you have a sort of system where you have architectures?
So like if you had a completely different database or whatever, no, I have not had that. Mostly what I try to do is I try to keep it more like refactoring in that let's just keep everything the same now, and once we get over to that other side, we can change it the way it needs to be. Yes?
When you estimate, let's say, 1.5 years work, how do you base your estimation? What things you...
So for the Delphi, I just seen their code, and I kind of have an idea that, a million lines, probably around a year type thing. But I, add some fudge factor in there. But what I normally will do is I'll go through, pull out all the references to external stuff, right? That's not theirs, that I'll have to map manually or potentially even for each occurrence of that, rewrite by hand. And then I can look at the types of, so, that's GUI code, that's a database layer, and then I have a feel for, GUI code's a little bit more difficult. The database, there's still the standard functions, it's a different library, but they'll probably work the same, and you kind of go through that. You get so I'll do both, the difficulty level. Then I'll also just do there's 10,000 things or whatever that I'm going to have to rewrite to, 10,000 rules. Then I'll do, how long would it take me to do an average rule, do some multiplication, add in some extra in there, and so that's how I come up with stuff. Yes?
Yes. If you have to translate another Delphi program, what's the percentage of the translator that you already did that you will be able to use?
Yeah, so a lot of it will already be covered. One of the things is that, we did do some external library stuff for that company itself. So, we'd have to redo that for another company. But, of course, most of the base Delphi is just going to go through no problem. So that's where I get my biggest win, but currently my sales department, which is me, hasn't sold another Delphi one. But any other questions? Where? Oh. So, yes, that's where I started out with, and I have basically a longer version of this talk where I do start out talking about the small talk ones. It's initially started out doing VSE to VA migrations. I'm using a tool called SMT, in which that tool used the refactoring browser's rewrites in it as part of their transformations at the bottom level. So, yeah, I have done several of those. No. If somebody has money. Any other questions?
What size of companies is asking for your services, particularly business?
So most of the time, medium-sized companies, because really large companies don't want to deal with somebody my size, But I have had it where large companies contact, other companies that will work with me, so you have the, how many middlemen do you want in there type thing, but any others? Okay, thanks.